Hi everyone, my name is Safia Singla and today I will be talking about two of the most important concepts in linear algebra. That's Gaussian elimination and LU factorization. So what are they? They are two basic methods to solve a system of linear equations using matrices. We manipulate these matrices to solve this equation. So how do we come to this matrix is we take the coefficients of all the variables and put them in a matrix. So 1, negative 2, and 1 is 1, negative 2, and 1. And this column is for the final constant terms. And then we get a matrix. So what's Gaussian elimination? The first technique of Gaussian elimination, also known as row reduction algorithm, is used to solve the system of linear equations using the row echelon form, and we can convert this matrix into a upper triangular form using a series of operations. So what's an upper triangular form is something of this type where the lower triangle of the matrix is all zeros. So this makes it easier to solve our final equations. What's row operations? Row operations are, for example, to convert these into zeros. What we do is we, for example, for this one, we multiply the row 1 with negative 2 and add it to the row 2. So negative 2 times 1 is negative 2, and when we add it, it becomes a 0. And we do it for all of the columns, and we get this matrix. And we also did another operation on the row 3 where we added negative 4 times of row 1 to it to get this. Next, we have come to this matrix and we convert it into this by multiplying negative 5 to row 1, row 2, and adding it to row 3. So now this was not this matrix, it was actually the row 2 and row 3 switched first, and then we moved on to this because that makes it easier to solve and that does not leave our matrix in fractions. So once we get this form, the zero echelon form, it makes it easier to solve our equation using back substitution. For example, this could be solved as 10z is equal to 10. So we get the value of z, and we put this here in y minus 3z is equal to negative 1, and makes it easier to solve. The next method is LU factorization. It is short for lower upper factorization, and it is another method to solve the system of linear equations. It decomposes the initial square matrix into a product of two triangular matrices, a lower triangle of this kind that's called the L, and an upper triangular matrix, which we saw earlier as well, of this kind. Now, for example, we have this system of linear equations, and the square matrix is just for the coefficients, and the constants make another singular matrix as C. And we have a different matrix of matrix X, which has all the variables. So AX is equal to C, which is true here. Now we will decompose this matrix A into two matrices to make this equation easier to solve. So we use the same row operations we used in Gaussian elimination to convert that matrix into this as well as this. So this is the L matrix, which has the upper triangle to be 0, and this is the upper matrix, which has the lower three to be zeros, lower triangle to be 0. Now, to solve this equation, what we do is we assume a new singular matrix Z with variables z1, z2, and z3, and find z1, z2, and z3 using this matrix and the initial C matrix, which gives, once we have the values of all the three z's, we use that to solve this this matrix. So ux, where x was our initial variables, is equal to the z matrix. So although in such a small number of equations, this is far more looks far more complex. When we have a huge number of uh, equations and a larger number of variables, this method is very useful for solving these system of linear equations. Thank you.